Welcome to solverfy.
To calculate the root mean squared velocity, we simply need to know the equation to calculate the root mean squared velocity, where it's the square root of 3RT over m. M is the molar mass, but it needs to be in kilograms per mole rather than grams per mole. T is the Kelvin temperature, and R is the universal gas constant at 8.314. So if we have helium, it has a molar mass in kilograms per mole of 4.003 times 10 to the negative 3 kilograms per mole. So at 0 degrees Celsius, it's 273.15 Kelvin. And we get 1,305 meters per second. But if we still have helium, but the temperature is now summertime, where it's 30 degrees Celsius, or 303.15 Kelvin, then we get something just a little bit faster, 1,374 meters per second. So this is helium at 0 and 30 degrees Celsius. So now for xenon, it's a little bit heavier. At 30 degrees Celsius, the setup will be the same as we did before at 303.15 Kelvin. The molar mass of xenon is 131.29 grams per mole, so it'll be 0.13129 kilograms per mole. And we see a much slower root mean squared velocity, 240 meters per second, a little bit less than 1/5 the speed that of helium at 30 degrees Celsius. There's no mass involved, no molar mass involved when calculating the average kinetic energy. The average kinetic energy is 3/2 R over Avogadro's number multiplied by the temperature. This then will give you the average kinetic energy of a single molecule or a single atom, which would be the case of xenon or helium because they exist as atoms, not molecules. So if we want to know the average kinetic energy per mole, we'll need to multiply this by Avogadro's number, 3,780 joules per mole. If we want to know the kinetic energy per atom, then instead of multiplying by Avogadro's number at the end, we simply stop right here, and we get 6.28 times 10 to the negative 21 joules per helium atom.